One, welcome to our presentation. We're Team Daybreak. Now let me show you how we work out the solution of the project to Pacman Capture the Flag. Our team used 3 advanced search techniques to achieve our goal. They are among color tree search, we call this MCTS technique, Q-learning, and A-star search. We try our best to eat as much food as possible in enemy's territory and define our own food. First, let's talk about MCTS technique. It is mainly used in advanced agent design. It starts rounds of simulations, and according to the result, it can estimate the reward of this simulation and give feedback to the whole search path, and then update the weight. The second technique that we use is Q-learning. Q-learning is one of the reinforcement learning algorithms. The goal of Q-learning is to learn a policy, which will tell the agent what action to take under each state. The most important part is the Q table. We initialize all the Q value at the beginning and update it according to the reward. In this project, we choose the best action with the maximal Q value in each state. The difficulty is the definition of the reward of each action state pair. We redefine the reward as the decrease of a distance to the food, which means if you take an action that can shorten the distance to your closest food, and the goal state is still distant, you will get 1 reward. The A-star algorithm is one of the most efficient search methods to search shortest paths. So we use it both in our offense agent and defense agent. The formula is expressed as Fn equals Jn plus Hn. Hn is the cost estimation from the initial state to the target state via the state n. Jn is the actual cost from the initial state to state n in the state space. Hn is the estimated cost of the best path from state n to the target state. Then I will show you some demo of the application of 3 techniques we use. This is the first demo, MCTS. Notice that the offensive agent in red team is moving in random fashion, ideally. We don't want our Pacman to go into this dead end, as there has no food and it also circles around randomly. The second demo shows how Q-learning performs in the tournament. In the first iteration, Q-learning agent is slow to respond to unknown cases. It gets stuck because it just chooses the shortest way to the closest food. But in its 40th iteration, it almost eats all the food and succeeds to return home. The third demo is our final submission, A-star search. It helps us find the shortest way. We can observe that the agent goes directly to its destination and never detour. Unlike other methods that sometimes make a random move, it always has a clear goal. Also, we utilize the domain knowledge to form our decision tree in order to help our agent to choose actions. During the project, we also faced some challenges. At the beginning, MCTS method will bring serious overtime issue. By reducing the number of iterations, we solve the overtime issue. However, the low iteration causes another problem, that offense agent always does some random actions. So we turn to the Q-learning. We find the Q-learning is slow to respond to a rapid chain, and it needs many iterations to actually learn a feasible policy. Finally, we choose A-star search with decision tree as our ultimate solution for offensive agent. It performs really well in tournament. The result is in the table as below. You can see our win ratio in these 4 days is 80%, 66.7%, 75%, 85.5%. In the end, we have some ideas that haven't been implemented. We plan to make 2 agents cooperate with each other. For example, we let the 2 agents chase the invader together, which can kill the opponent's Pacman who has eaten numeric dogs in our territory. Another potential improvement is the enforcement of deep neural network for Q-learning agent. It can make the Q-learning agent more generalized in different mazes. That's all the work we did in this project. Thanks for watching.